Now we are going to discuss the scalar product. The first type of product, that is the scalar product. What is this scalar product and how to find the scalar product of two vectors? For this, let us consider two vectors that are vector A and vector B. See, this is vector B and this is vector A. Vectors are represented by bars. So A bar is a vector, B bar is also a vector. Suppose these two vectors are inclined at an angle theta. That means the angle between these two vectors is theta. Now I want to calculate the dot product of these two vectors. So how to calculate the dot product of these two vectors? The dot product means we have to denote it by a dot, that is A dot B. A bar dot B bar is equal to AB cos theta. That means the dot product of two vectors is defined as the product of the magnitudes of the two vectors, and cosine of the angle between them. Try to understand. अगर हमारे को मालूम करना है स्टूडेंट्स कि भाई डॉट प्रोडक्ट फाइंड आउट करना है टू वेक्टर्स का, तो आप क्या करेंगे, इंडिविजुअल वेक्टर्स के मैग्नीट्यूड्स लेंगे. You have to multiply that magnitudes, individual magnitudes with one another, and cosine of the angle between them you have to consider, और उससे भी आप उसको multiply करेंगे. That means it is the product of the magnitudes of the two vectors as well as the cosine of the angle between them. So in exam they may ask you, by giving A vector and B vector, they may ask you what is the angle between the two vectors. So you can use this concept. How to use this concept? From this I can write cos theta. This is cos theta is equals to A dot B, that is A bar dot B bar by AB. This A and B, what I am considering, they are the magnitudes of the vectors. Now one more thing, the very important thing I can say, the component of A along B, that is what we have, the rectangular component of A along B. So for this what I do, let us see. Rectangular component of A along B, that is A bar along B bar. How to calculate the rectangular component? The first type of question you can expect on this, the second you can expect on this, and the third one also I'm giving you, that is the rectangular component of vector A along vector B. So for this, let us take the figure once more time. This is vector B and this is vector A, and this is an angle theta. This is A and this is B, angle is theta. So we know how to resolve this into rectangular components. If this is A, then this can be written as, if I resolve this, then this is what, A cos theta. That means only along B we are saying, only along B. We are not saying perpendicular to B. Along B, if it is perpendicular to B, then it will be B sine theta. Perpendicular to B, B sine theta. We are resolving this along this one. So this is A, so this will be A cos theta. So what I can say here is that rectangular component of A bar along B bar, that is A cos theta. Just A cos theta. Now this A cos theta can also be determined by another formula. Which formula? By this one again. So if I use this formula again I am writing, that is cos theta is equal to A dot B by AB. A dot B by AB. So I need the rectangular component of A along B. So what I have to do, I have to find A cos theta. A cos theta हम find out करेंगे. I know what is this A cos theta from this also. How? Just you take this A this side. So A into cos theta, that becomes A cos theta, that is equal to A dot B by B. So we have two formulae, students, to calculate the component of A along B. That is either A cos theta you can go, या नहीं तो students आप कैसे जा सकते हैं, A cos theta का formula पता चल गया हमारे को. What the formula we are getting? A dot B, that is A bar dot B bar by B. So the two formulae we can have. This is also the rectangular component of A along B. So the definition and the formula is this one. Now let us come to the examples. What examples we can give. The first example, work done by the force. Work done, work done by the force. Work done is a scalar quantity, but force is a vector quantity. That means here what we are doing, try to understand the example 1. If I say work done by the force, by a force. So formula, if I want to write, work done is equals to F dot S. What is F? F bar. What is F bar? F bar is a force vector. S bar is the displacement vector. Try to understand, F bar is a force vector. S bar is a displacement vector. F is a vector quantity. S is a scalar. S is also a vector quantity. If you are multiplying these two vector quantities with a dot product, then the resultant we are getting a scalar quantity. I'm not writing any bar here. You can see I'm not writing W bar. I'm just writing W. The reason, what is the reason? Because W, work, is a scalar. And what is this force? Force is a vector. Displacement is also a vector. That means what I am doing, I am multiplying one vector with another vector. Try to understand what I am doing. क्या कर रहा हूं students? देखिए, one vector I am multiplying one vector with another vector, and the result I am getting as a scalar. So what type of product it is a scalar product. So therefore I am checking under the example of scalar product. So this is W is equals to F dot S. It is something like A dot B. F dot S is something like A dot B. तो हम इसको कैसा लिखेंगे? A dot B को क्या लिख सकते हैं हम? AB cos theta. AB cos theta. In the same way, F dot S, we can write the work done as W is equals to Fs cos theta. Then what is this theta? Theta is the angle between the force and the displacement. I repeat, theta is the angle between force and displacement. Here theta is the angle between A and B. There the theta is the angle between force and displacement. Here I'll write for your understanding. Theta is angle between F bar and S bar. Now second example. The second example what we can give, that is the power. Power is what? What is power? The rate of doing work. Rate of doing work. That means how much work we are doing in how much time. कितना काम किया जा रहा है बेटा कितने टाइम में. Try to understand students. कितना काम किया गया कितने टाइम में, that is decided by a physical quantity, power. So I take that only. So power is equals to work by time, rate of doing work. But what is this work? Work already we have seen the formula F dot S. F dot S, that is the work divided by time T. So this is the power. You can see clearly it is a dot product of two vectors and we are getting a scalar. Power is a scalar. So therefore I have taken power as an example for a scalar product. Now one more thing what we need to have here is, this is the displacement. ये displacement होता है students और ये time. और आपको पता होना चाहिए students, displacement by time, that is a velocity. Displacement by time is a velocity. Velocity by time is an acceleration. So therefore displacement by time I am considering it as a velocity. So therefore formula for power F dot displacement by time, that is velocity. So this is F dot V. It is same as A dot B. So A dot B क्या लिखे हम? AB cos theta. In the same way F dot V, what we are going to write? FV cos theta. I hope you have understood what is a scalar product, how to calculate the scalar product, along with the component of A, that is component of A vector A along vector B, and along with that we have seen example 1 and example 2. I hope you have understood this. Now students, the next topic is the properties of scalar product. What are the properties? We have seen what is a scalar product. What are the properties they are going to, that scalar product is going to obey, that we are going to check. We have to go for the 4 properties, and in advance I am saying the last property, 4th property, is the very important property. Let us go for the first one by one. The first one, scalar product, that is also called as a dot product, obeys commutative law. Commutative law. It obeys commutative law. What do you mean by this commutative law? It means that if you multiply a vector A with vector B, you are going to get the same result as if you multiply another vector, that is another condition, we can say vector B with vector A. It is something like in mathematics, we have 2 into 3. We get the same result if you multiply 3 into 2. So that is what you call it as the commutative law. So here it obeys commutative law means A dot B, because this is also called as a dot product. A dot B, that is A bar dot B bar, you are going to get the same result if you multiply B with A. So this is the commutative law. The next one, scalar product obeys distributive law. Scalar product obeys distributive law. Distributive law. What is this distributive law? Let us see. If suppose I multiply vector A with B and C. Try to understand, students. I'm multiplying vector A as a dot product I'm using with the result of B plus C. I'm going to get the same result if I multiply A with B, A with B, that is with the dot product itself. I'm taking the help of dot product. That's why I'm writing here dot plus A dot B is over then A dot C. So either you multiply A with B plus C, or you multiply A with B, A with C, and you add it. The result will be the same for this as well as for this. That means these are the 2 properties. The next one, scalar product of 2 parallel or anti-parallel vectors A bar and B bar. Scalar product of 2 parallel or anti-parallel. Parallel means we should consider the angle 0. Anti-parallel means we should consider what I can say 180 degrees. So both we are saying for parallel as well as anti-parallel vectors, what it will be like. So for parallel vectors means theta 0. This is for parallel. This is for parallel. And if I take theta as 180 degrees, this I have to take for anti-parallel. Parallel, you know, both are in the same direction. Same direction. Anti-parallel means just they will be opposite to each other like this. So in this condition, you have to consider 180. In this condition, you have to consider it as 0. Both I have written. So I'm writing for parallel. So it is what? A dot B is equals to AB cos theta. Cos theta means what? Cos 0, because I'm writing for parallel, I said. So cos 0 is how much? It is 1. Cos 0, it is 1. So therefore, the result what I am getting here is just AB. Because cos 0, it is 1. I'm writing here for you. So it's just AB. And what is cos 180? It is minus 1. So result what you are going to get here is A dot B is equals to AB cos 180. Cos 180 is minus 1. So therefore, it is minus AB. Hope you have understood the third property also. The last and the very important. Scalar product of 2 perpendicular vectors A bar and B bar. Perpendicular means, students, you should know perpendicular means theta as 0. Sorry, theta as 90. Perpendicular means 90. Theta already we have taken 0 here. Theta means it is 90 here. So if theta is equals to 90, let us see that dot product A dot B is equal to, this is what, AB cos 90. And you should know what is cos 90. Cos 90 is 0, and 0 into something you are going to get completing as 0. That means A dot B is equals to 0. The very important property, problems can be framed on this. That means the scalar product of two perpendicular vectors is always 0.